The goal of 2.2 is being able to graph certain functions without having to have a graphing calculator. And one thing that helps us in graphing is finding x and y intercepts. How do you find the x-intercept of a graph? You put in 0 for y. The x-intercept is where the graph crosses the x-axis, and if the graph is sitting right on the x-axis, then no matter what x is, y is 0. The y-intercept is where the graph crosses the y-axis, and no matter where the graph crosses the y-axis, x is 0 at that point. So to find the x-intercept, you let y be 0, and to find the y-intercept, you let x be 0. And that gives you some important information, not all the information you need, but it gives you some important information that you can use to graph an equation. All right, y equals negative x squared plus 2. I think, let me double check the directions on page 102. I think all you're asked to do there is find the x and y intercepts. That's number 8. Actually, 1 through 20 say sketch the graph and label the x and y intercepts. So we want to graph the equation as well. But let's find the intercepts. The x-intercept, let y be 0. And how would you solve that equation? You could either subtract 2 from both sides, and then you'd have to divide both sides by negative 1. And that's perfectly okay. It would be a little bit faster just to add x squared to both sides. But you get the same thing either way, it doesn't matter. So what are the x-intercepts of that graph? Plus or minus square root of 2. When you took the square root of both sides, you didn't forget the plus or minus. So my two x-intercepts are x is negative square root of 2, 0, and x is positive square root of 2, 0. We're sitting right on the x-axis, so y is 0. And then the y-intercepts are usually easier to find than the x-intercepts. When you let x be 0, what do you get for the y-intercept? Two. So that's the ordered pair. When x is 0, y is 2. Now this is just a little test of what you remember from college algebra. Do you remember what the graph of y equals x squared looks like? If you do, show me with your arms. Y equals x squared, not this, y equals x squared. What? All right, timid people. This is y equals x squared. Show me y equals negative x squared. Show me y equals negative x squared plus 2. What does that plus 2 do to the graph? Shifts it up 2. All right, so here's a good enough graph of this, even if it's not exactly right. It's a good enough mental image so that if I graphed it on a graphing calculator and got a circle, I'd go, whoa, that can't be right. Square root of 2 is about 1.4. Let's just put a dot at about a half. I'm sorry, 1.5. I didn't get that in the right place. 1.5. I like I didn't have those two dots right there. And the y-intercept is 0, 2. That's because my parabola has been shifted up 2 units. Again, we're going for rough mental image. And that's rough, but it's good enough to tell me, yeah, that's what it's supposed to look like. Do you remember from college algebra how it changes the graph if your y is squared instead of your x? Y equals x squared was this. What's x equals y squared? Sideways parabola. All right. If the leading coefficient is positive, it opens to the right. If it was negative, it would open to the left. So because we're a little bit behind, I'm going to skip that problem. I know you know how to find the x and y intercepts. If you found that and know that it's a sideways parabola that opens to the right, that would be plenty good enough. Same thing on number 20. I know you could graph that, or it's supposed to be one of the graphs that you have memorized from college algebra. What's y equals the square root of x? Remember the shape of that graph? If I squared both sides, I'd have x equals y squared. What does x equals y squared look like? This is y equals x squared. This is x equals y squared. If I took x equals y squared and took the square root of both sides, I'd have y is plus or minus square root of x. Plus or minus square root of x would be the whole sideways parabola. But if I just have the positive square root of half x, it's just the top half of that parabola. This is a sideways parabola. This is the top half of a sideways parabola.
So if it was negative, it would be the bottom.
Exactly. So these are just things that you should remember from college algebra. In my happy bubble, you do. In reality, you may have to work on brushing up your basic functions. But if you let x be 0 to find the y-intercept, let y be 0 to find the x-intercept, and then gave me a half a parabola, that would be plenty good enough on number 20. We also talked about circles in college algebra. Standard form of a circle. Some books call it center radius form, and I like center radius form better because that's what you can tell just by looking at the equation. The center is HK, the opposite of both guys subtracted from the H, or the X and the Y, and the radius is the square root of the constant on the right-hand side. If an equation is given to you in that form, then it's easy to see the center and the radius. If the equation's not given to you in that form, there are certain tricks we have for getting it in that form so that we can see the center and the radius. One thing before we do that though, how do I, just looking at an equation, how do I tell, oh, that's going to be a circle? What about an equation causes me to know this should be the equation of a circle? Both squared, that's half of it, but that could also be an ellipse. So there's something just a tiny bit more than both variables are squared and positive. No. Both variables have to be squared with the same positive coefficient. If both variables are squared, but one of them has a negative coefficient, it's a hyperbola. If both of them are squared with positive coefficients, but those coefficients are not the same, then it's an ellipse. You're starting at the center and you're not going the same distance left, right as you go up and down. That's what forms an ellipse. If the coefficients are both positive and the same number, then it's probably a circle. It could possibly be just a point or no graph. We're not going to talk about those right this minute. Number 30 is definitely a circle. It's in what some books call center radius form, some books call standard form. I can see what's subtracted from the x before it's squared, and I can see what's subtracted from the y before it's squared. What's the center of that circle? What could I put in parentheses with the x? If I wanted it to look exactly like x minus h squared, what number could I put right there that wouldn't change the problem? A 1 would change the problem. A 0. I could put a 0 there and it wouldn't change the problem. So take a stab at that center one more time. It's not 1, 2, it's what? 0, 2. The center is 0, 2. It's what is subtracted from the x and what is subtracted from the y. If I say what's subtracted from that y, the answer is positive 2. This is y minus positive 2. So you
y plus 2 be negative.
exactly right. And what's the radius of that circle? Oh, I'm sorry, my hand was faster than my ears there. It was 5. Square root of the right-hand side. Because this equation says that number on the right-hand side isn't the radius, it's the radius squared.
Do our homework too.
I might as well take your test. All right, so to graph a circle, just start at the center and count 5 units from the center, left, right, up, and down. This is going to be a bigger circle than I have room for, but let's just play like I didn't have tick marks. All we're going for is rough mental image, right? So that'll suffice as rough mental image. Dylan, do you believe me? Is that good enough rough mental image for you? I won't laugh at your circles if you don't laugh at my circles.
Mine has straight edges.
It's okay. It's okay. What about 34? What would we have to do to 34 to get it in this form? Notice this form, the coefficient in front of both parentheses is 1. I need it in that form where both coefficients are 1 before I can say what the center and the radius are. How could I make that happen on number 34? I'm sorry, what? Pull out a 9. If I pulled out a 9, what could I do with it to get it off the left-hand side? It's multiplied, so you get rid of it by dividing. You could just divide both sides by 9. If you divided both sides by 9, you'd have x squared plus y squared equals 4 9s. So what is the center of that circle? 0, 0. Nothing subtracted from the x before it's squared. Nothing subtracted from the y before it's squared. The center is 0, 0. And what's the radius? 2/3. All right. If I took standard form of a circle that had not been shifted left, right, up, or down, if I just took a circle with center 0, 0, like x squared plus y squared equals r squared, to solve that for y, I'd have to subtract x squared from both sides, r squared minus x squared. And if I was solving for y, what else would I have to do? That would still be y squared until I did what? Take the square root of both sides, and as soon as you said take the square root of both sides, what bells and whistles went off in my head? Don't forget the plus or minus. I subtracted x squared, and then I took the square root of both sides, not forgetting the plus or minus. That y equals plus or minus, actually going back to here, if I had x equals y squared, I know it's a whole sideways parabola. And if I take the square root of both sides, I know the positive square root will give me the top half, and the negative square root will give me the bottom half. The same thing is true of circles. If I solve that for y equals positive square root is the top half of a circle, y equals negative square root is the bottom half of the circle. So this is the top and the bottom half. What do you think would give me the left and the right half? What do you think?
X equals plus or minus r squared minus y.
Solve for x. X equals plus or minus square root of r squared minus x squared. Gives me the left and right half of that circle. The positive gives me the right half, the negative gives me the left half. So in looking at number 34, I know that if I squared both sides, it would take me more room than I have room for right there. But if I squared both sides and added y squared to both sides, I'd have x squared plus y squared equals 25. And you see that that's what I'd have. If I squared the right-hand side, squaring a negative makes it positive. Squaring the square root just leaves you what's under the radical. And then I added y squared to both sides. Is this original equation the top half, bottom half, left half, or right half of that circle?
That should be y squared instead of x squared.
What should be y squared instead of x?
Your left, right half.
Oh. Yes, thank you. Typo right there.
I just looked up.
No, I'm glad you said that. So which half of the circle is x equals negative? It's the left half of that circle.
Is that because it's a negative out front?
Yes. Here's how I keep straight which half of the circle that I'm looking at. If I graphed, I need to leave y'all more room. I'm sorry. I mean, I write very small and I still run out of room on my notes. I'm trying to save paper for some reason. And I should just give up on saving the rainforest and give you plenty of time to write. I know, but it's still paper from some rainforest in the Amazon. And I hate mowing it down. Here's what I think that helps me remember which half of the circle I have. In that circle, which half of the circle has all positive y's? The top half, left half, top, bottom, left, or right, which one has all the y's positive? The top has all the y's positive. That's y is positive square root of something. Where are all the y's negative? Bottom half, y equals negative square root gives me the bottom half. Where are the x's all positive? Left, right, top, or bottom? Right, that's x's positive square root. The left half comes from x's negative square root. All right, so here's something we didn't do in college algebra, and we're not even going to get to start 2.3. Here's something we didn't do in college algebra. In college algebra, I gave you 2 points that lay on a line and asked you to find the equation of the line. And I gave you a point and a slope, and I asked you to find the equation of the line. We didn't do any, I'm going to tell you something about the circle, you find the equation of the circle. But that's what we're ready for here. We just have to know the standard form is this. And I'm hoping that whatever information you give me, I can figure out how to fit it into that form. So number 46, what do we know about the circle? It's tangent to both axes. Its center is in the 4th quadrant, and its radius is 3. I don't see how I can plug, other than plug in the 3 in place of the R, I don't see anything that tells me what I can plug in place of HK there. So what's the strategy? I'm going to say draw a picture. Somebody say draw a picture. Draw a picture, that's always a strategy. If you can't think of what else to do, see if you can draw it. So, I don't know about the tangent to both axes. I can show you definitely center in the 4th quadrant.
If it's tangent to 2 of the axes in the 4th quadrant and the radius is 3, wouldn't that also make it x3 and negative 3 for y?
Yeah, absolutely. And maybe you could figure that out without the picture. Maybe that helps you, maybe seeing the picture helps you figure that out. But in the 4th quadrant, if the radius is 3, that means this distance is 3, and the x-coordinate of the center is 3. It hits the x-axis right there. It hits the y-axis right here, which means the y is negative 3. The center of my circle is 3, negative 3. And I'm going to draw that circle just to make sure I've satisfied all the conditions that I was given. Is that a circle that's tangent to both axes? Touches both axes only once? Yes. Is the center in the 4th quadrant? Yes. Is the radius 3? Yes. Now that I'm looking at that picture, it's easy to give you the equation. What would it be? Beautiful. And then double check that. The center of this circle would be positive 3, negative 3. That's right. And the radius would be 3. That's right. So it's not that the problem was difficult. We're just being asked to think about something in a way that we've never had to think about it before. We're having to figure things out instead of monkey see, monkey do. That's the big leap from college algebra to calculus, pre-calculus. What about number 48? All I'm given is the endpoints of a diameter, and that doesn't fit anywhere in the equation of the circle. A is negative 5, 2. B is 3, 6. And if that's endpoints of a diameter, this is going to be a bad one, I can tell. Not as bad as I was expecting. That's my diameter. And so using the midpoint formula, Samantha, let me say this is A, this is B. What would I be finding by using the midpoint formula?
Center of that line.
I'd be finding the center of the circle. So the center of that circle is the midpoint of the line segment AB. So the midpoint of line segment AB would be -5 plus 3 over the 2. Just average the x's, average the y's. You double check yourself every step of the way. -2 divided by 2 is -1, 8 divided by 2 is 4. The center of that circle is -1, 4. Hey, I didn't miss it by much. It's like right here instead of right on the y-axis, but it's right about here. What else do I need to know to find the equation of that circle? The radius, and how do I find it? The radius is going to be the distance between which 2 points? I could either
Doesn't
use A and C, or I could use B and C. Anybody mo? I'm not going to finish this problem, but I'm just going to say I could use the distance formula to get the radius, and then I could find the equation of the circle. All right. A note. I know we're not going to get down here to the D part, so let me just say we've already talked about what gives you the upper half, lower half, right half, and left half of circle. The upper and the lower half, you solve for y, and the right and the left half, you solve for x. And there's an example just like number 62 on page 97. So you'll have one in your homework. You can look at that example. The other thing that we need to hit real quickly is how do we take an equation in this form and get it in center radius form? I suspect that's a circle. I'm not 100% sure it's a circle. The x and the y are both squared with the same positive coefficient, but depending on what the radius is, that could turn out to be just a point, or it could turn out to be no graph. And if we have time to do all 4 of these in 9 minutes, you'll see. Make yourself a note right here. Complete the square of x squared plus bx, add half of b squared. Number 54, that's called general form of a circle. I can still tell it's probably a circle because the x and the y are both squared with the same positive coefficient. Other than that, I can't tell you anything about the circle because it's not in center radius form. Yet in general form, in center radius form, takes this trick called completing the square. And to complete the square of x squared plus bx, you just take half of b and square it. What I mean by that, just for a quick example, if I gave you x squared plus 10x, to complete the square would mean to make that a perfect square trinomial. And to make that a perfect square trinomial, you take half of 10 and then square it. So what would you have to add to make that a perfect square trinomial? Half of 10 is 5, square it. 25, that's a perfect square trinomial. And now it looks like something that's goes in the standard form of a circle. If this were part of the standard form of a circle, I'd say the center is at -5 something. So that's the goal when we're given something in general form. We want to get it in center radius form so that we can see the center and the radius. To do that, and I'm going to go quickly here, you group the x's. I'm going to leave a little bit of room for completing the square, but you group the x's, you group the y's. I only have one term with a y in it. That's the y squared. And you move the constant to the other side. What would I have to add to complete the square on the x's? Half of 10 is 5, 5 squared is 25. I can't go around just adding 25s whenever I feel like it. If I have an equation and add 25 to the left-hand side, what do I have to do to get an equivalent equation? The same thing, add 25 to the right-hand side. Now the nice thing about completing the square is, what does that factor into? The perfect square trinomial now, how would it factor? Sine of the middle term, it would factor into that. And the y, if I needed to, I could write it as y minus 0 squared. And the right-hand side just cleans up to 7. So what is the center of that circle? 5, 0. And what's the radius of that circle? No. Square root of 7. Which is 2 point something. I could get on a calculator if I needed to graph it. But completing the square is the tool that we use to get general form to standard form so that we can see the center and the radius. Number 4, just 54 is just one step harder because I don't just have a 1x squared and a 1y squared. I'm still going to group my x's and group my y's and move my constant to the other side. But in order to complete the square, I have to have a 1x squared and a 1y squared. How could I make that happen? You could factor out a 4 from both groups. Is that still equivalent to the line above it? Yep, and I'm OCD, I'm checking that every step of the way. The floors are still problematic. How could I move them? You can divide by 4. Now in this step, I'm going to leave myself room, just so I don't have to recopy the whole problem again. I'm going to leave myself room to complete the square because that's what's coming next. What do I have to add to complete the square on the x's? Half of 4 is 2, and then square it. I add 4 to the left. I have to add 4 to the right. What do I have to add to complete the square on the y's? half of 6 is 3. 3 squared is 9. I add 9 to the left. I have to add 9 to the right. That first group factors into x plus 2 squared. The second group factors into y plus 3 squared. And the right-hand side would be negative 31 over 4 plus 1352 over 4 would be 21 over 4. If I did that real quickly, correct. And so the center would be negative 2, negative 3, and the radius would be square root of 24, 1 over 4. All right, at 2 minutes, I'm going to go into hyperspeed here. Oh, shoot. X squared minus 6x, half of, 9, that's supposed to be 9. And then that would be 9. What happens on number 56 when I complete the square and end up with a 0 on the right-hand side? What's the center of that circle? The center is 3, 2. What's the radius of that circle?
0.
What the heck is a circle with center 3, 2 and radius 0?
It's just
It's just a point. It's just the point. 3, 2. 3, 2 is the only solution to that equation. And I'm not going to do it because we don't have time, but on number 58, if I completed the square and ended up with a negative on the right-hand side, what's a circle with a square root of a negative?
Okay, it's imaginary.
All right, the homework is bottom of the page. Bye, Dylan. Just throw it right there for me.
Okay, so I didn't finish a lot on it.